Hello, everyone. It's Mr. Bronze coming at you again. Happy Thursday to everybody. Gearing up for the end of the week here, and certainly one day closer to my triumphant return on Monday. All right, so just as a reminder again, some of you have heeded my advice from earlier in the week and went back and completed some assignments that you were missing. Please make sure you get on that. The marking period, I believe, is only for another 3 weeks after this one. So you don't want to get backloaded with too many assignments that you're trying to make up right at the very end there. So please take a look at that. If you have any questions, let me know. I could certainly let you know if you're missing anything and what that might be. Okay, so that said, we're going to continue today with Chapter 12, our ongoing discussion with counting principle and permutations. Before we get to anything new, though, got a little warm-up question for you here I'd like you to take a look at. So see if you can determine how many three-letter words can be formed from the letters in the word question if each letter is used only once. Okay, so if the sub in the room wouldn't mind, just pause this video for, say, 3 or 4 minutes. Let everyone see what they can do with this question, and then when everybody's ready, just start it back up again. All right, so guys have had a few minutes to take a look at this, and we talked about permutations and specifically this type of question. And we said if we are arranging items, in this case we're arranging letters, we want to know how many items or how many objects do we have. So if we look at the word question, we've got 1, 2, 3, 4, 5, 6, 7, 8 different letters. So we're going to arrange 8 letters. So it's a permutation of 8 letters, but now we're taking them in groups of 3. So let's write out our notation first. So we have 8. We always start with the total number of objects. We have a permutation, so P, and then how many we're taking within each group. And of course, these values here on the left and the right, the left, we call that's our N, that's a number of objects. And on the right, R, that's the size of the group that we are looking at. We want to make those into subscripts. Okay, so now, oops, I got to get out of my subscript notation. Let's go back to the menu. There we go. Okay, so what does 8P3 look like? Remember, permutations, the first letter, which is N, and let me get rid of this little line. There we go. The first number, that's our N, that's the number we start with. And now we're going to begin using multiplication, and we're going to count down. Now remember, the second number on the right side tells us how many factors we're going to multiply together. So we only need 3. So we have 8 times 7, which is 2, and then times 6, that gives us our third. So we have 8 times 7 times 6. All right, let's see. What is 8 times 7 times 6? We'll go with the old school computer calculator. 336. 336 3-letter words. And we're done. All right, so a quick review of permutations and a very common style question with the letters in the word question. All right, so hopefully we are good to go. Today we're going to expand our conversation that we've been having regarding permutations, and now we're going to bring in repetition. And actually, let's go back to the warm-up for a second. If you noticed, all the letters in the word question were different. There was no repetition of letters. So what we're going to do, the road we're going to go down today, is we're going to ask, well, what happens if we do have letters that repeat? How does that change this little process that we're working on? So I give you a little something to think about. When an infant is rocked to sleep, the parent is trying to lull or calm the baby to sleep. All right. So we're going to examine 3 words from the sentence. And the 3 words we're going to examine are calm, lull, and baby. Each one of those 3 words contains 4 letters. So they're the same size with regards to how many letters there are. But we see that the word calm is 4 different letters, no repeats. The word lull has an L that appears or repeats 3 times, and baby has a letter that repeats twice. So let's take a look at how we're going to handle this. So we're going to begin with the word calm. So how many different 4-letter words can be formed from the letters of the word calm? Now, we know this is very similar to the warm-up question. So here we've got a total of 4 objects, right? There's 4 letters in the word calm. We're going to use all of them. So we're going to take a groups of 4. So we have 4P4. But we're going to go old school for a second. So let's first write this down. We know it's a permutation of 4 things taken 4 at a time. It's easy enough for us to write 4P4, right? And a different type of notation, alternative, as we see here, using the factorial notation. So whenever we have a permutation where N and R, the numbers on the left and the right of P are the same, that would be the same as that number factorial. And it gives us exactly the same answer. So there are 24 possible words in the word calm. Now, I wasn't going to make you sit here and write them all, so I gave them to you. Here are all 24 distinct arrangements of the 4 letters in the word calm. Very exciting, right? You guys are probably falling right out of your chairs right now. All right, now I wanted to show you that for a reason, because there's 24 of them, which seems like a lot. And there's a lot because all 4 letters are different. So let's build on that. So we know that our answer is 24 words. And we know that from looking at the list, okay, wrote out every 4-letter word, plus we went ahead and said, you know what, we've got this nice little notation of a permutation or factorial we can use, and I'll guess the answer pretty quickly. All right, great. Now let's compare that to the next word, lull. How many different 4-letter words can be formed the letters of the word lull? Now, this is our first example of permutations with repetition because the letter L is repeated in the word. Now, if I ask you to list all the different words you can make with the letters in the word lull, you wouldn't get 24 like you do with calm. And the reason why is those 3 L's are exactly the same. Even if we switched them around, if we left the U in that second spot in the word lull and we moved the L's around, it's a different arrangement, but the word's the same. So it's repetition. We don't want to count it twice. Here's the only 4 words we can make. L-oo, l-ool, lull, and ol. Those are my 4 words. That's my very, very weak attempt at comedy. So, how can we get an answer of 4 words using a formula? Because we can't do 4P4, right? This is a permutation of 4 letters taken 4 at a time, but we've got repetition. We're not going to get 24 different results. What is different about lull from calm? 3 L's. So, a couple of bullets I gave you. Our list of possible words is much shorter because there's no difference among the 3-letter L's. They're all the same. An L is an L is an L. So without repetition, we would simply use 4 factorial, like we did with the word calm. Now, it's not working here. Since L appears 3 times, we're going to take that 4 factorial, but now we're going to divide it by 3 factorial. which would be the number of permutations of the letter L. All right, so let's take a look at this now. So here's what we've got. We're going to take 4 factorial. Let's get some arrows going. So this on the top, oh my goodness, 2 different arrows. Let's try that again. There we go. What is that guy? What is that 4 factorial? That's your total number of objects. So why don't we make a little note here? Total objects. Let's bring that over. All right, cooperate with me. Oh, there we go. I need this. There we are. Total objects. So when we have repetition, we start with the total number of objects we have. We had 4 letters altogether. And then we're going to divide that by the amount of repetition. And so now we've got ourselves a formula where we're taking what we already know about permutations and factorials, and now we're bringing in this idea that if there's repetition, we've got to make that number smaller. We can't use just the factorial alone. We need 2 factorials. One on the top for your total objects, one on the bottom for your repetition. And that is how we're going to start putting it together. All right. So let's grab that last of the 3 words. So now we got the word baby. And I tried to get Justin Bieber to come by and sing it, but he wasn't available. And I don't like him anyway. All right. So, and don't ask me to sing. Number of permutations of 4 letters taken 4 at a time. Again, you think at 4P4 until you look at it and say, wait a minute, though, I've got repetition. 2 of the letters are identical, so I can't just do a 4P4. I can't just do a 4 factorial alone. I've got to account for that repetition. There's 2 B's there. So at the bottom, there's our 2 factorial. So we're going to run with 4 factorial over 2 factorial. Now remember, guys, in your calculator, we have factorial. Okay? So if you have your calculators with you, take them out. Check this out. You're going to begin by pressing your math button. Okay. Once you press math, then you want to get over to the PRB probability menu. And you do that by using your right arrow. Once you get to PRB, and that's the same menu where we find permutations. And I believe it's choice number 4 will give you the factorial, the exclamation point. So you can do 4 factorial divided by 2 factorial. And I would use my fraction notation. Okay, remember your fraction notation. Alpha, y equals, enter. Those are your 3 buttons. Press your green alpha, then the y equals in the top left, then enter. That will give you a fractional format. You drop your 4 factorial on the top, your 2 factorial on the bottom, and you are good. So we see 12 distinct words from the letters in baby. Why do I keep doing that? All right. Ooh, pink baby. So in general, we've got a pattern, folks. Here it is. If we're taking trying to find the number of permutation of n things, taking n at a time, so we're taking all of them at the same time, but some number of these things are identical, we have n factorial over r factorial. So it's your total over your repetition. And that is the name of the game. So with that said, don't look at the answers. Let's try practice number 1. How many different 6-digit numbers can be written using all of the following 6 digits? We have a 2, a 2, a 2, a 2, a 3, and a 5. So think about what we just said. Total number of objects, factorial, divided by the amount of repetition, factorial. See if you can put that fraction together as you're listening to my soothing voice. All right, time's up. So we have a total of 6 different digits here, right? 4 2s, a 3, and a 5. So we begin with 6 factorial. But then we see there are 4 number 2s. So we see a repetition 4 times. So we have to divide by a 4 factorial. Now, the reason why I wrote the factorials and then I wrote it the long way, it's just old school me. Factorials, we know we count down from that number and we multiply all the way to 1. If you don't have your calculator with you, this actually isn't a bad calculation because you can cancel factors. So you can cancel the 4s, the 3s, the 2s, the 1s, and then it's just 6 times 5 is 30. Okay, so a question like this, your calculator's not around, you can still write it out and get the job done. All right. How about practice number 2? How many different 7-letter words can be formed from the letters in the word divided? Now we're going to work through this one together. And here's why. This is the first example where you see repetition happen more than one time. Look at the word divided. 7 letters in total. You have 3 D's, but you also have 2 I's. So you're seeing repetition in 2 distinctly different objects. So let's put it together. We're still going to start with the total up top. So we still have our 7 factorial up in the top of the fraction. So we know, we've established that in the denominator, in the bottom, we need to put our repetition. So however many examples of this repetition we have, we're going to put them all down there. So we've got 3 D's, so we need a 3 factorial. And we got 2 I's, so we also need a 2 factorial. So we put them both down there. And either order will be just fine. So 7 factorial, and this is why I strongly suggest, and let me write it out for you here. Alpha, and we're going to go from there to your, don't forget, will be your, oh, I thought that was an arrow. Let's get rid of that. Let's just do this. Alpha, y equals, and enter. So here's the thing. If you don't use these 3 buttons, the alpha, y equals, enter, the calculator is not going to be very cooperative. So if you use alpha, y equals, enter, you get the fractional format, and we can type it in just like this. If you don't do it that way, if you do 7 factorial and then you hit your division button and then you put in 2 factorial, 3 factorial, the calculator will get somewhat creative with the order of operations, and we don't want that to happen. We want the calculator to do our bidding, and that is that. All right, let's wrap it up with one last question. Here the numbers got a little big, but big numbers are fun too, right? So we got Frank. Frank's got a garden. Frank has 8 tulip bulbs, 10 daffodil bulbs, and 28 crocus bulbs. He likes the crocus. Release the crocus. No, that's the kraken. All right, and how many different ways can Frank plant these bulbs in a row in his garden? So it's an arrangement. He's got maybe he's got like this long, flower bed right up against his sod, and he plants them all in a row, that kind of thing. So how many different arrangements can Frank make? Well, what's our total? We got a lot of bulbs in total, so we need to add them up first. So if we add our 8 tulip bulbs, our 10 daffodil bulbs, and our 28 crocus bulbs, we get 46. So we got 46 bulbs altogether. So we got a 46 factorial, and you can already see how big this number is going to get. We've got 3 instances of repetition. 8 tulip bulbs, that's 8 times we got repetition. 10 daffodil bulbs, 10 times, and 28 crocus bulbs, 28 times. We need a factorial for each, and here they are. So using your fractional notation, you're going to plug this into the calculator, and your calculator is going to give you this huge value. So Frank's got quite a selection of ways that he can actually arrange all these bulbs. Now, your calculator, when you get it, has a little e. So if you put this in your calculator, and some of you may be doing this right now, what you're going to see is 1.23 with a few more decimal places after it, then a capital E and a 17. Remember, that's your scientific notation. Anything that comes after the E is the exponent for the number 10. And with scientific notation, we always round to 2 decimal places in this class, unless told otherwise. So we go 1.23 times 10 to the 17th power. So, Frank, go nuts, buddy, with your bulbs. All right, so that wraps it up for today's lesson on permutations with repetition. As always, if you have any questions, you can put them in the stream or email me. In the stream, you have an attached homework assignment. So with the rest of this period, you can certainly work on that and then complete that by the end of the day today and submit it by 11:59 p.m. to get credit for your homework. All right, and tomorrow is Friday, TGIF. So we'll have some stuff for you for tomorrow. So for now, enjoy the rest of your day, and we'll see you guys on Friday. Have a good one. Bye-bye.